Welcome to some more video notes real quick about, we're going to be looking at some midpoints and writing equations. We're mostly going to be writing equations, but we're still setting up some of our skills in order to do some of the more complex tasks later in this unit. But it requires that we have a general understanding of how to write an equation, a linear equation, and how to find midpoints, and then we're going to start putting those things together. Let's start with super basic, when you're just given the information and you got to put it into the equation. So a point and a slope, it's going to go through -2, 5, and have a slope of -9/2. So how would I draw that into a picture? It's going to be at -2, 5. It starts here, and it's going to go down 9, which puts me at y equals -4. And it's going to go over 2. So I need the slope or the equation for the line that kind of creates this line segment. We can make it a little bit thicker, make it a little bit easier to read there. But that's our line that's going to be on the graph. It's actually quite easy if you scroll up to the top and click on this link here to open up this pre-made graspable math equation setup. This second one here, you have a handful that you can look at. You can write these equations in many forms, but this second one is the one I'm going to be using so much today. So first of all, it has a point that it goes through, -2 and 5. And all I got to do is fill in the boxes with the slope and the x and y value. The slope is going to be here, where it's 9. We'll say -9. And that's going to be -9/2. So there's my slope. And for the x, I just type in what the x value is right next to the x. So it's going to be -2. And for the y value, it is 5. So I'm literally just putting things into this template here. One thing that I think is probably good to do is clean up when we have a double negative sign and that turns into a plus. And this would be more than likely the equation you are trying to match to, like on some kind of assessment. So I'm going to screenshot this equation. So this first easy one, we're just substituting pieces in. We don't have to do much manipulation beyond that. So now let's look at this one. It says 2 points through -5, 5, and 2, 1. I'm going to refresh this page so I can start from scratch. It's just helpful for me. So I first need to find the slope. Well, let's plot this line and see if that helps us in finding the slope. So it's going to be at -5, 5, and then it goes to 2, 1. So -5, 5 starts all the way up here, and 2, 1 is going to be there. Again, let's make our line a little bit extra thick. It looks like I drop 1, 2, 3, 4 for my rise, and then I go 5, 6, 7 for my run. So it's going to be 4/7, and it's negative. So if I'm thinking about how to put that over here, it'd be 4/7, and one of those needs to be negative, so like a -4/7. But I want to show you how we can also use a calculation to confirm that. So I'm going to do that here. With this setup, the m equals, that's where we're referring to the slope. So I'm going to put in the difference in the y values up top, because that's my rise. So we start out at 5, and we get to 1, and we started at -5, and we went to 2. Oops, -5, and then we went all the way to 2. Okay. So now when I look at this, that's going to work out to, or calculate, simplify, however you want to describe it, as a negative 4/7. Now, if the negative's in the denominator, the numerator, or kind of out front here, those are all equal. So I could rewrite this as negative 4/7, and it's the same number. These two fractions are the same number. Then I just need to substitute one of these x and y coordinates. I'm going to go ahead and choose the first one. So I would say negative 5. Because I chose negative 5x, I'm going to choose the 5y. One last thing to kind of make things look just a little nicer is those double negatives create a plus, because when you do the opposite of subtract, that's really just addition. Let's screenshot not just the equation, but also the calculation I did for the slope. We'll put both of those in here together. Now let's start to step up our game. These symbols here mean parallel. So we're going to say an equation that's parallel and a point. But this is a little bit easier, and then we'll get into an equation perpendicular and a point, easy and hard. So first, if it's parallel to this equation, notice that it's already given me the solved equation. It's solved for y. So then all I have to do is look at the coefficient of x. In this case, that's negative 7/3. So my fraction that's going to go in this equation here as a coefficient to x is just negative 7/3. There we go. So that's my slope. Why? Because a parallel slope has the same slope. It's probably good to write myself a note that so that I don't forget it. And now if I wanted to try and graph this, we could do that, but I really just want to focusing on graphing the one line that's going to go through 3, -2, but has a slope of negative 7/3. So that's actually going to go kind of off my grid there, which is a little bit harder, but that's okay. Let's edit this. So I have 3, -2, and it's going to go negative 7/3. So I'm going to go 1, 2, 3, down 7 and over 3, or that'd be the same as 3.5 and 1.5. So about there, 3, -2. We'd be looking at a line that looks like about this. And it's going to go through that point 3, -2 there. So how do I start filling this in? The x is 3, so it goes with the x on the inside here. And the y is -2, so I'm going to change that outer number to a -2. It is a little sloppy in math equation writing to put plus minus or minus minus or plus plus together. So we tend to combine them into whatever combination those two things multiply to. So plus minus is really minus. So this would be our final equation for something that's parallel to that slope, but goes through this point here. All right, let's look at the next one. Why is this one a little bit harder? Well, I don't know what the slope is. I'd have to solve for y first, so I'm going to do that. I'm going to say 3x minus 5y equals 15. I'm going to do another equation in here. And what I want to do is solve for y. Well, I can subtract 3x to both sides. And 3x minus 3x is, let's try that again. Let's go back to this line. Oh, it doesn't like moving coefficients in that way. So that's a little bit harder, but that's okay. I'm going to, let's go back to this line. and I'm going to say equals, and I'm going to say plus 5y on both sides. We'll do it that way. And that puts these two 5y's together, puts a 5y over there. And then I'm going to subtract 15 to both sides. This minus 15 will subtract with that 15. So I have 3x minus 15 equals 5y. I could divide by 5 on both sides. That gives me just y. And now I can divide this 5 into both of those terms, and it gives me a 3/5. So I have a lot going on here, but it tells me that the slope is 3/5. That's super helpful. So I'm going to put that in here. I can shrink it down just a little bit because we also want to write this equation. So we know the slope is 3/5. That's helpful. 3/5. And the x value it gave us is 2. And the y value is -1. Again, when you have two symbols right next to each other, it's just common to clean it up and see what they multiply to. So that would be a negative there. So it's 3/5 x minus 2 minus 1. We have our equation now. We'll shrink this down so we can fit these next to each other. There we go. Now let's start looking at perpendicular. So again, parallel, as a review from earlier, same slope. Perpendicular means we're going to be doing opposite reciprocal. What does that mean? That means opposite means if one of them's positive, the other one's going to be negative. And reciprocal means take the fraction of the slope and flip it. Reciprocal is when it's like 1/2 becomes 2/1, or 3/4 becomes 4/3. So the easy version, y is already by itself. We look at the coefficient of x, or the number multiplied by x. So slope is -2. So if slope is, original slope is -2. Opposite reciprocal slope is equal to positive 1/2. So my new slope for the perpendicular is positive 1/2. Cool. So I can go into my little equation plug-in here and say that the coefficient of the x is going to be 1/2. And I'm going to put a number, it's going through this point, -3, So the x is -3. And on the outside, it is 1. There we go. So I have an algebraic formula. I have a couple of negative signs here, and a negative times a negative is a positive. So I'm going to get x plus 3 instead of x minus -3. And we'll take a picture of that. So a little bit easier on that one. If I wanted to graph these two lines, I could graph them in the picture here, but I'm not going to spend that extra time here. We just got a lot going on. Okay, this next one, we have quite a bit going on in the equation that we need to decipher. I'll reload my math.new so I can work out some of these slopes. We have 5x plus 1/2 times y minus 5 equals 0. Okay. Let's see what we can do. I would like to try and get y by itself. That's kind of like my first idea. And if I'm trying to get y by itself, I can move some things around to the other side. I can also multiply. So what I think I'm going to do first is just try to get rid of the fraction. I'm going to multiply everything times 2. Let's see what that does. Well, on the right side, it's just 0 still. But now this 2, when it gets multiplied in, becomes 10x, 2 times a half, and minus 10. But that turns this into just a 1y. There's a lot to simplify there to get it to be just y. Why is that helpful? Because now I can move, or I can try to move the other things to the other side. Let's move this y in front. So we have all this. We have y plus 10x minus 10. So I'm going to move things to the other side. Will it let me move this? No, it's not going to. Would it let me move just the y? Yeah, we can do that. So I'm going to go back to this line. We'll move just the y to the other side. And then we're going to divide by that negative. Or multiply it. And so now that the y is by itself, what happens with my slope then is my slope is negative 10. So I had to do a lot of work here just to figure out what the slope is. But then my slope is not going to be negative 10. It needs to be the opposite reciprocal. So the original slope equals negative 10 over 1. The opposite reciprocal is going to be positive 1 over 10. Okay, so my new slope, positive 1 over 10. And the xy value that I'm going to be going through is x is 2, and the y is 3. There we go. We have the equation now. It was a lot of work to figure out the original slope, but getting it written into the equation was just a little bit of substitution. Putting in the slope and the x value and the y value. Okay, now to wrap this up, it's, in my opinion, probably the easier of the calculations. It's just midpoint. Okay, so the midpoint is kind of the average between 2 points. So what we're trying to do then to calculate the midpoint is we want an x1 plus x2 divided by 2, and we'll copy this. On your notes, this should be ready for you. And y1 plus y2 divided by 2. So it's almost easier to do it visually. I think it's way easier to do it visually. When you're trying to find the midpoint between 2 points, you just need to go halfway left and right and halfway up and down. So my up and down here is 3. So what's halfway? It's going to be 1.5 right there. Similarly, in the x direction or horizontal, we move 1, 2, 3, 4, 5, 6. And halfway for that is going to be right at this value there. So how would I calculate that? Well, the x values, I would say negative 2 plus 4, and take the average. Divide those two together. So I'm going to have negative 2 plus 4. And I'll group that and divide it by 2. So negative 2 plus 4 is 2. 2 divided by 2 is 1. And that is the x value for the midpoint. For the y value, I'm going to do the same thing. We have negative 1 plus negative 4. And then we're going to divide that by 2. So that turns into negative 5 divided by 2. It doesn't want to do it because it's a decimal approximation, so I'll force it by doing a double click. It says, okay, that's negative 2.5. So these are kind of my x and y values for the midpoint. I'm going to capture those to put into my calculation. And there we go. If I'm only given the points, well, let's plot them and make it easy with a little bit of visual. So negative 3, 6, is one of the values, and 1, -2. So -3, 6 is going to be just off the screen. So let's pull this down a little bit. -3, 6 is up here. I think it said 1, -2, which would be there. And this vertical change goes from 6 down to -2, and the horizontal change goes from 3 over to -1. This is a little bit easier to kind of split in half. I have 2 on each side in the horizontal. You could draw a straight line up to hit that diagonal, and this has 1, 2, 3, 4, 5, 6, 7, 8. So I got to go 4 on each side to split my horizontal, and that gives me this point right there. So I should get a point at -1, 2. This point right there. So let's go back to these calculations and see if we can get those same ideas. For the x, instead of -2 plus 4, it's -3 plus 1 divided by 2. And for the y value, we started out at 6. So that's a +6. And we're averaging it with -2. Remember, to average something, you just add the two things together and divide by 2. So -3 and 1, -2 over 2 is -1. That's looking good for our x value. And for the other one, we have 6 minus 2 is 4. 4 over 2 is 2. So -1, 2. So our visual and our calculations both confirm that the xy midpoint would be at -1, 2. Now for each of these, I didn't write it yet, so let's put it in here. The midpoint would be 1, -2.5. And for the other one, the midpoint would be at -1, 2. There we go. That's calculation of midpoints. Lots of equation writing and slope finding with those equations. Again, we're just setting up skills that are going to help us as we put this all together into complex shapes on a coordinate plane.